Every bit left that spacecraft over 16 hours ago. Every bit is telling us something new that we haven't known before.
The most distant human-made object in the universe is sending usable information to Earth again.
For decades, humanity has pointed telescopes toward the heavens, searching not just for planets, not just for distant galaxies, but for anomalies. Those rare moments when something in the cosmos refuses to follow the rules we've spent centuries establishing. When observations don't match predictions. When data contradicts every model we've built. History shows that every paradigm shift in science began this way. Not with confirmation, but with discomfort. Not with answers, but with questions that shouldn't exist. And now, in the cold darkness beyond Mars, that discomfort has returned. What began as a routine observation by the James Webb Space Telescope has quietly transformed into one of the most unsettling discoveries in modern astronomy. The target was 3I, Atlas, officially designated as the third confirmed interstellar object ever recorded passing through our solar system. At first, it was catalogued like its predecessors, another ancient visitor from deep space, a frozen remnant ejected from some distant star system millennia ago, now drifting silently through our neighborhood before continuing its eternal journey. But buried within Webb's infrared data was something that should not exist, something no peer review process was prepared to handle. Something that forced researchers to check instruments repeatedly, hoping the anomaly would disappear. It didn't disappear. What Webb detected was light, but not scattered light from a distant star, not reflected sunlight bouncing off ice and rock, not thermal glow from solar heating. Artificial light. The emission detected did not behave like any known comet, asteroid, or natural interstellar body ever observed. It did not flare randomly. It did not fade predictably. It did not scatter across the spectrum the way natural objects do. Instead, it appeared controlled, focused, regulated, emitted with a precision that follows no known physics of reflection or refraction. A glow that shouldn't exist on an object that supposedly has no power source, no systems, no design. The first response from astronomers was denial. Instruments malfunction, software glitches occur, data pipelines introduce artifacts. Every assumption favored error. Every verification protocol was designed to make the anomaly collapse under scrutiny. It refused to collapse. Webb observed it again. Different filters, different exposure times, different processing algorithms. The signal remained. Other telescopes confirmed portions of the data. Independent teams ran their own analysis. The conclusion converged from multiple directions simultaneously. This was real. Deep in the void of interstellar space, an object no larger than a city block was emitting light as if powered from within, radiating energy without visible interaction with its environment, glowing with an efficiency that natural processes cannot achieve. What made this detection especially disturbing was its clarity. This wasn't a marginal signal hovering at the edge of instrument sensitivity. It was clean, repeatable, persistent, statistically significant across every observation window, and completely impossible to explain naturally. At that moment, the investigation shifted. Researchers were no longer merely cataloging an unusual visitor. They were documenting behavior. And behavior implies intent. Intent implies design. Design implies intelligence. The question stopped being, what is this object? And became, who built it? As Webb continued staring into the darkness, one truth crystallized in research facilities around the world. Humanity was no longer observing a rock passing through the solar system. We were witnessing technology. And if this object was engineered, then someone or something sent it here. The discovery that changed everything. 3I, ATLAS was first detected on July 1, 2025, by the Atlas Survey Telescope in Chile. In the initial hours, it appeared unremarkable. Survey telescopes catalog thousands of objects monthly. Most are asteroids, defunct satellites, or cometary fragments following predictable orbits. This one was different from the start. The velocity was wrong. Objects gravitationally bound to the Sun follow elliptical paths with speeds dictated by orbital mechanics. This object was moving too fast. Not slightly too fast. Dramatically, unmistakably too fast. Within 48 hours, orbital calculations confirmed what only happens once in a generation. The trajectory was hyperbolic. This object had not originated from our solar system. It arrived from interstellar space, was passing through, and would never return. That alone placed 3I Atlas in one of the rarest categories in astronomy. Only 2 interstellar visitors had ever been confirmed before: Oumuamua in 2017 and comet Borisov in 2019. Each forced scientists to reconsider assumptions about matter exchange between star systems. But even among this exclusive group, 3I Atlas stood apart immediately. Its brightness was the first clue. Based on distance, estimated size, and expected surface composition, the object should have been faint, barely detectable even with powerful instruments. Instead, it glowed with a consistency that violated every brightness model. Natural objects don't behave this way. Comets brighten as volatile materials sublimate near the sun. Asteroids reflect light based on rotation, surface texture, and composition. Their brightness fluctuates. It varies. It tells a story about what they're made of and how they're moving. 3I Atlas did neither. It simply remained steady, constant, regulated. As more observatories joined the observation campaign, the anomaly deepened. The light curve, which graphs brightness over time, showed no randomness. Natural rotation causes brightness to oscillate as different surface areas come into view. Irregular shapes create chaotic patterns. Outgassing creates sudden spikes. This object showed none of that. Its output remained smooth across extended observation periods, controlled, almost filtered. What disturbed researchers further was the duration of this behavior. Over weeks of continuous tracking, the signal didn't drift, it didn't degrade, it didn't destabilize despite crossing environments where radiation, particle impacts, and thermal stress should have caused visible changes. Interstellar travel is brutal. Objects are bombarded by cosmic rays, micrometeorites, and extreme temperature gradients. Natural materials erode, they weather, they change. 3I Atlas appeared unchanged, as if insulated, protected, designed to endure exactly what it was experiencing. Comparisons to Oumuamua began circulating immediately. That earlier visitor had also defied explanation, but its behavior was chaotic. It tumbled erratically. Its reflectivity varied wildly. Those irregularities could plausibly arise from natural fragmentation or unusual composition. 3I Atlas was different. It was calmer, cleaner, more deliberate in every measurable way. That calmness itself became evidence. Chaotic systems reveal their origins through disorder. Natural objects are messy because nature is messy, but ordered systems imply constraints. Constraints imply structure. Structure invites uncomfortable questions. Questions like, what kind of object maintains perfect stability while crossing light years of empty space? That question prompted a decision. If any instrument could determine whether this light was natural or artificial, it was the James Webb Space Telescope. Webb was not designed to hunt for aliens. It was built to observe the earliest galaxies, to peer through cosmic dust, to see what no telescope had ever seen before. But its capabilities made it uniquely suited to answer a fundamental question about 3I Atlas. Was this object merely reflecting sunlight, or was it generating energy on its own? The answer to that question would change everything. What Webb saw in the darkness. James Webb observes the universe in infrared, seeing heat signatures invisible to human eyes or optical telescopes. Every object above absolute zero emits infrared radiation. By measuring that emission, Webb can determine temperature, composition, and energy distribution with extraordinary precision. When Webb turned its instruments toward 3I Atlas, researchers expected to resolve a simple question. Was the brightness coming from reflected sunlight or mundane thermal processes like residual heat from formation or radioactive decay? The data returned neither explanation. What Webb detected was a clear internal energy signature. The emission originated from within the core of the object, not from its surface. This immediately violated fundamental expectations about how small celestial bodies behave. Small objects in space have no internal heat sources unless they're young enough to retain formation heat or contain radioactive elements. 3I Atlas was interstellar, meaning it could be billions of years old. Any formation heat would have dissipated eons ago. Radioactive decay produces specific isotope signatures. None were detected. Yet the object was radiating energy outward from its center as if something inside was generating power. The thermal profile made the mystery worse. Natural heat distribution is chaotic. Hot spots form where materials concentrate. Cold zones appear where density drops. Cracks, fissures, and compositional variations create thermal gradients. 3I ATLAS showed none of that chaos. Its thermal output was remarkably even, almost regulated, as if internal structures were managing heat flow deliberately, preventing stress concentrations that would cause material failure. Long-term monitoring deepened the concern. Observations separated by days, then weeks, showed no measurable drift in emission patterns. Natural thermal processes degrade over time, heat sources cool, materials redistribute, equilibrium changes. This signal remained stable, suggesting either self-correcting mechanisms or materials capable of maintaining thermal equilibrium indefinitely under extreme conditions. What Webb did not detect proved equally significant. There were no chemical byproducts, no erosion signatures, no evidence of surface breakdown despite crossing interstellar space where radiation should have caused visible damage. The object appeared preserved rather than weathered. In astronomy, absence often speaks louder than presence. The absence of decay forced a realization that spread quietly through research teams. If 3I ATLAS could emit energy without deterioration, it wasn't merely surviving the journey between stars, it was designed to endure it. At that point, the language changed in internal discussions. Researchers stopped asking what the object was made of. They started asking what systems it might contain. Power generation, thermal regulation, energy management. These aren't questions asked about rocks. They're questions asked about machines. The boundary between natural object and artificial construct had been crossed, not through speculation, through measurement. The light that shouldn't exist. What elevated the detection from unusual to alarming wasn't just that light was being emitted, it was how that light behaved. Natural light sources are inefficient. Energy scatters. Photons radiate in all directions. Wavelengths spread across broad spectra. This inefficiency is fundamental to natural processes. The light from 3I ATLAS violated this principle entirely. Spectral analysis revealed something that made astrophysicists pause mid-conversation. The emission was narrow-band. Instead of spreading across the spectrum like sunlight or thermal glow, the light concentrated in specific wavelengths with almost no bleed into surrounding frequencies. This kind of spectral purity doesn't occur naturally. It requires filtering, focusing, or generation methods that control photon behavior at fundamental levels. Even more disturbing was the efficiency. Nearly every detected photon served a purpose. There was minimal waste, minimal scatter, minimal loss. The light maintained coherence far longer than natural processes allow. Researchers modeled energy loss over distance. Natural emissions degrade predictably as photons disperse and interact with interstellar medium. This signal maintained integrity across distances where natural light should have dissolved into noise. It behaved as if deliberately confined, as if designed to remain readable even across vast interstellar distances. The emission pattern also displayed temporal consistency. Observations separated by weeks showed the light remained within tightly controlled parameters despite the object moving through varying radiation environments and gravitational fields. This level of regulation is difficult to achieve even with active monitoring systems. Achieving it passively would require materials and design principles beyond current human capability. Some physicists proposed the light might be waste heat from advanced energy conversion. Others argued it resembled communication protocols more than power leakage. Both interpretations led to the same conclusion. The light was not accidental. More troubling still was the absence of noise. Natural emissions fluctuate unpredictably due to microenvironmental changes, quantum effects, and chaotic processes. This signal did not. It appeared filtered, smoothed, refined. At conferences that would follow months later, after initial shock faded into analysis, comparisons to human technology became unavoidable, not because the mechanisms were identical, but because the logic was: reduce waste, maximize clarity, control output. Nature does not optimize this way. Evolution produces solutions that work well enough. Engineering produces solutions that work precisely. This light worked precisely. The signal within the signal. When long-duration datasets were compressed and analyzed, another layer of the mystery revealed itself. Buried within the steady emission were patterns, subtle variations that repeated at regular intervals. At first, these were dismissed as instrumental artifacts or natural resonance effects. But as more data accumulated, the patterns became undeniable. The variations repeated every 19.7 minutes with extraordinary precision, not approximately every 20 minutes. Exactly 19.7 minutes. Consistent across hundreds of cycles spanning weeks of observation. Natural processes don't produce this kind of precision. Orbital mechanics create periodicities, but they drift as gravitational influences change. Rotational periods vary as angular momentum redistributes. Even atomic processes show quantum fluctuations. This periodicity was locked, stable, deliberate. Statistical analysis showed the odds of such repetition occurring naturally were vanishingly small. Not impossible, but requiring coincidences stacked upon coincidences. Occam's razor suggested a simpler explanation. The pattern was intentional. Some researchers attempted to interpret the variations as power cycling or rotational effects, but these explanations failed when cross-referenced with orientation data. The signal remained consistent regardless of the object's spatial alignment or its position relative to the Sun. It didn't respond to external conditions. It simply continued. That suggested purpose beyond environmental interaction. If this was a beacon, it was meant to be detected by something else. If it was telemetry, then someone might be receiving it. Either interpretation forced an uncomfortable conclusion. Earth was not the intended audience. This realization shifted the emotional tone of the investigation. The question was no longer, are we being contacted? It became, are we accidentally eavesdropping? The patterns themselves resisted straightforward interpretation. They weren't simple enough to be natural resonance, nor complex enough to be random noise. They occupied an uncomfortable middle ground where meaning seemed present but remained tantalizingly out of reach. Some analysts noticed the intervals corresponded loosely to prime number sequences. Others suggested Fibonacci relationships. A few proposed the patterns might be self-describing, containing information about how to decode subsequent transmissions. None of these interpretations could be confirmed, but all shared a common thread. They required intelligence to produce the course that corrected itself. While astronomers puzzled over the light, orbital mechanics specialists noticed something equally disturbing. The object's path was changing. Initial trajectory calculations predicted 3I ATLAS would pass through the solar system on a specific arc, sweeping past the inner planets before departing into deep space. Those calculations were based on fundamental physics, gravity, momentum, conservation of energy. The object was not following those predictions. The deviations were subtle at first, fractions of a degree, small enough to attribute to measurement error or gravitational perturbations from distant planets. But as more data accumulated, the deviations remained consistent across independent tracking stations. This consistency ruled out error. Something was causing real, measurable changes to the trajectory. Gravity couldn't account for it. The object was too far from major planets for significant gravitational deflection. Solar radiation pressure was insufficient given the object's estimated mass and surface area. There was no evidence of outgassing that could produce thrust through jet effects. The only remaining explanation was propulsion. Minimal, carefully controlled propulsion. The course corrections themselves were elegant. There was no brute force redirection, no violent change in velocity. Instead, the adjustments appeared optimized, conserving momentum while subtly altering orientation. This is the kind of efficiency engineers achieve when fuel is limited and mission longevity matters. When every gram of propellant is precious. When waste cannot be tolerated. The new trajectory had clear implications. The corrections brought 3I ATLAS closer to the plane of the inner solar system, optimizing its vantage point. From this adjusted path, the object gained improved observational geometry of the solar system's most complex bodies, including Earth. That realization spread through research circles like ice water, written in careful technical language, buried in orbital mechanics reports, was an unavoidable conclusion. Something had adjusted its course to get a better look at us. Researchers stopped using passive language. The object was no longer drifting or passing through. It was navigating. And navigation requires awareness of surroundings, understanding of gravitational fields, and decision-making about where to go next. Those capabilities don't exist in rocks. They exist in spacecraft. Materials that shouldn't exist. As Webb and ground-based telescopes continued observations, spectroscopic analysis revealed another layer of impossibility. The object's surface reflected light with extreme efficiency in certain wavelengths while absorbing others completely. Natural materials don't behave this selectively. Stone, ice, metal, organic compounds, all reflect and absorb light across broad ranges. The patterns may vary, But they're messy, overlapping, and inconsistent. 3I ATLAS showed selectivity that approached theoretical limits for engineered surfaces. Portions of the object reflected light like polished metal, not weathered metal, not oxidized metal, polished, as if manufactured. What made this more disturbing was the uniformity. Natural metallic compounds, when exposed to radiation and micrometeorite impacts over long periods, degrade. They oxidize, pit, and erode. Surfaces become rough. Reflectivity drops. The surface of 3I ATLAS showed no such aging. Its reflective properties remained consistent across observation windows separated by weeks, suggesting either active maintenance or materials inherently resistant to decay in ways unknown to materials science. Then came the absorption lines. These spectral signatures identify what elements and compounds are present by showing which wavelengths of light are absorbed. The absorption spectrum didn't match anything in existing databases. Not common elements, not rare isotopes, not known chemical compounds. Some features resembled theoretical predictions for metastable atomic configurations, structures that exist only under extreme quantum confinement conditions. Such materials have been discussed in theoretical physics papers but never observed in nature or created in laboratories. If those interpretations are correct, the implications stagger the mind. Producing such materials would require precise control over electromagnetic fields, particle behavior, and atomic structure at scales requiring technology far beyond anything humanity has achieved. The composition also explained several earlier mysteries: the object's resistance to thermal stress, its structural stability during interstellar travel, its immunity to radiation damage, everything aligned with deliberate construction rather than natural formation. Materials scientists who reviewed the data found themselves cornered by evidence. Either unknown natural processes exist that perfectly mimic advanced manufacturing across multiple domains, or 3I ATLAS was built. And once that possibility is accepted, even reluctantly, every other mystery becomes less mysterious. The light makes sense if there are power systems. The course corrections make sense if there are propulsion systems. The patterns make sense if there are communication systems. The only thing that doesn't make sense is why it's here. The flare that changed everything. On December 18, 2025, as 3I ATLAS approached the inner solar system, something happened that forced even the most skeptical researchers to confront reality. The object's luminosity suddenly increased. This wasn't gradual brightening from solar heating. It was abrupt. Within less than 2 minutes, brightness surged by 38%. Overwhelming background noise and triggering automated alerts across multiple observatories on 3 continents. Natural outbursts are chaotic. They spike irregularly, overshoot, oscillate, and decay unpredictably as physical processes run their course. Comets flare when volatile pockets are suddenly exposed to sunlight. Asteroids brighten when impacts expose fresh material. This didn't behave that way. The emission rose sharply, stabilized at a new baseline, and remained there. No turbulence, no gradual fade, no secondary flares. It resembled a controlled transition, like a system deliberately shifting operating modes. The timing couldn't be ignored. The flare occurred exactly as the object reached optimal observational position relative to Earth, not before, when it was still approaching, not after, when it had passed, at the precise moment when Earth was most visible from its perspective. Coincidence strains credulity when timing is this precise. Orbital recalculations began immediately. Independent teams ran models assuming every possible source of error: instrument drift, data lag, software bias, gravitational perturbations. Each possibility was systematically eliminated. The numbers converged. The object's trajectory had changed again. The shift was small, measured in fractions of a degree, but undeniable, and it brought 3I ATLAS even closer to optimal alignment with Earth's orbital plane. Gravity couldn't explain it. Solar pressure was insufficient. There was no mass loss, no outgassing, no debris cloud. The only remaining explanation was thrust. The language in classified briefings reportedly shifted at this point. According to sources who spoke anonymously to astronomy journalists, agencies stopped calling 3I ATLAS an object. The term no longer fit. You don't describe something that regulates energy, alters course, and times its actions to coincide with observational geometry as passive. You describe it as active. And once activity is acknowledged, Intent becomes impossible to ignore. The signal we sent and the response we received. As evidence mounted, a controversial decision was made. The SETI Institute, after intense internal debate, decided to actively signal 3I Atlas. The message was carefully designed. No language, no cultural symbols, no assumptions about shared biology or sensory systems, only mathematics, prime numbers, universal physical constants, the hydrogen line frequency, a signature of intelligence stripped of all specificity. The transmission was sent from a radio telescope array on December 14. The signal was focused, powerful, and directed precisely at the object's projected position. Then came waiting. At the speed of light, the signal would take approximately 42 minutes to reach 3I ATLAS and another 42 minutes for any response to return. Assuming anyone was listening, assuming anyone would respond. 72 hours later, a return pulse was detected. The response was not a mirror of the original signal. It was off frequency, slightly distorted, and incomplete, but the timing was precise, too precise. The delay matched the calculated round-trip light travel time with an accuracy of less than 3 seconds, across hundreds of millions of kilometers, through dynamic space where signal propagation speeds vary slightly with plasma density and gravitational fields. That precision ruled out reflection. It ruled out natural interference. It ruled out coincidence. Something had received our signal, understood it required response, calculated the appropriate timing, and sent something back. What unsettled researchers wasn't just that they got a response. It was that the response demonstrated understanding of relativistic signal delay, proper frequency adjustment for relative motion, and awareness that acknowledgement was expected. These are not natural processes. These are communication protocols. The content of the return signal resisted immediate interpretation. It didn't contain obvious mathematical sequences or repeated patterns, but waveform analysis showed structure, organization, information density that exceeded what noise produces randomly. Whether that information was meaningful to us or simply confirmation that our message was received remains unknown. But the exchange had occurred. We reached out, something reached back. And that changed everything. The silence that followed. Within days of the signal exchange, something unexpected happened. Updates about 3I ATLAS from official sources became sparse, then vague, then stopped entirely. Data pipelines that had been publicly accessible were restricted. Research teams working on the object were quietly reassigned. Public-facing astronomy bulletins that had been regularly updated went silent. The European Space Agency released a brief statement about instrument recalibration. NASA's updates became generic status reports devoid of specific findings. Even reputable astronomy journals began pulling back coverage or publishing only sanitized summaries. Silence in science is rarely accidental. The scientific method thrives on transparency, peer review, and open data sharing. When that flow stops, it's usually for one of two reasons. The findings are wrong and require extensive verification, or the findings are right and someone decided the public shouldn't know yet. Given the multiple independent confirmations across different instruments and research teams, the first explanation seemed unlikely. Independent observatories attempted to fill the information gap. Amateur astronomers, university programs, and private research groups continued observations, but their findings were quickly drowned in a flood of misinformation and speculation online. Without authoritative institutional voices providing context, the signal fractured into rumor. Every observation could be interpreted multiple ways. Every anomaly spawned a dozen contradictory theories. What was once a cohesive scientific investigation became fragmented, contested, impossible to follow clearly. History has shown what happens when discovery meets containment. Roswell, the pioneer anomaly, the wow signal. Once information is restricted, trust erodes, speculation multiplies, and the truth, whatever it is, becomes harder to distinguish from fiction. Some researchers believe agencies are simply exercising appropriate caution, ensuring data is validated before making extraordinary claims, preventing premature panic based on incomplete analysis. Others suspect something darker, that the truth has been confirmed privately and was deemed too destabilizing to release publicly, that governments have decided humanity isn't ready. Regardless of motive, the effect is the same. The flow of information stopped, and in its absence, uncertainty became the dominant narrative. What this means for everything. If 3I Atlas is what the evidence suggests, then this moment represents a boundary in human history, not a border we crossed, a boundary that found us. For thousands of years, humanity has wondered whether we're alone. That question has shaped philosophy, religion, science, and culture. It's defined how we see ourselves and our place in the cosmos. This discovery doesn't answer that question with certainty, but it shifts the probability distribution dramatically. Because if 3I, ATLAS was built, then someone built it, and if someone built it and sent it here, then we are no longer alone in the way we believed. Even if the object is ancient, operating on instructions programmed millions of years ago, even if its creators are long extinct, their legacy remains. Technology crossing the void, intelligence echoing across time. That changes everything about how we understand our position in the universe. What makes this especially unsettling is the object's behavior. It didn't announce itself. It didn't warn us. It didn't seek dialogue on our terms. It simply arrived, observed, and will eventually depart. That suggests a form of intelligence unconcerned with our recognition or approval, an intelligence that doesn't need our validation, that doesn't require our understanding. We are not the audience for this object. We're something it passed while en route to somewhere else, or something it was sent to examine. Either way, we're not in control of this interaction. That represents a profound psychological shift. Humanity has always imagined first contact as dramatic, ships landing, messages received, negotiations beginning. We imagined ourselves as active participants. This contact, if that's what it is, unfolded quietly, through data points, through subtle anomalies only detectable by our most advanced instruments. It happened not because we were ready, but because something else decided it was time. Perhaps 3I, Atlas is only one of many. Perhaps objects like this pass through stellar systems regularly, cataloging planets, measuring technological development, reporting back to something we can't yet imagine. Perhaps we were evaluated. Perhaps we passed some threshold that triggered the flare and the course adjustment. Or perhaps we failed some test and the object simply marked us for future reference before moving on. We don't know. And that uncertainty may be the most unsettling aspect of all. The universe that watches back. James Webb was built to peer deeper into space and time than any telescope before it, to see the first galaxies, to watch stars being born, to detect the chemical signatures of distant atmospheres. It was not built to find evidence of intelligence, but that's exactly what it may have found. What Webb revealed about 3I, Atlas is this. The universe is not empty in the way we thought. The silence we interpreted as absence may simply be indifference, or patience, or observation from a distance so vast we barely register as interesting. The light Webb detected didn't behave naturally because it isn't natural. The object doesn't move randomly because it isn't random. The patterns don't emerge from chaos because they were designed to convey something specific to something specific. Just not to us. That realization forces humanity into a new role. Not explorers pushing outward into an empty frontier. Not observers peering into a silent void, but subjects within a larger system we don't control. The question is no longer whether intelligent life exists elsewhere. The question is whether we're prepared to exist knowing that something out there is aware of us, that we've been seen, measured, cataloged, and that whatever conclusions were drawn, we weren't consulted. Perhaps this moment will be remembered as first contact, or perhaps it will be remembered as first confirmation that contact operates on terms we don't dictate. The object continues its journey, Webb continues to observe, data continues to accumulate, and somewhere, in research facilities around the world, people are trying to understand what it means that we are no longer alone. If this story matters to you, if you believe these questions deserve attention and investigation rather than silence and speculation, then stay with us, subscribe, share this with people who think deeply about humanity's place in the cosmos. Because stories like this don't end when data stops flowing. They end when attention fades, when people stop asking questions, when institutions can quietly archive findings without public pressure for transparency. Every major discovery in history lingered in uncertainty before clarity arrived. Galileo's observations, Einstein's predictions, the cosmic microwave background, each required patience, scrutiny, and collective attention before acceptance. This moment is no different. What we choose to watch, question, and remember shapes what science is permitted to investigate next. If 3I, Atlas is only one of many, then the universe didn't merely notice us. It sent something to look closer. And that possibility deserves more than silence. It deserves answers.